So I think Dimitri's stories really show how, I mean, in some sense, astronomy works. And we cannot travel out to these distant stars or galaxies to study them, and everything that we learn about them is through light. And so that's really amazing if you think about all the torturous paths that astronomers go through to extract out, the very last bit of information from the light that they're gathering from telescopes. And two of my stories will highlight some of that as well. But my first story is actually closer to home, and it has to do with the moon of Jupiter, Europa, which we saw a really close-up image of earlier. The picture that Dimitri showed was from the Galileo spacecraft, which orbited Jupiter for about a decade and took images like this, as well as taking really high-resolution images of the surface and showing a lot of the icy features. When Europa was first imaged by the Voyager spacecraft, um, you, planetary astronomers were amazed by the fact that it looked like a smooth cue ball, in the sense that it was white, it looked very smooth, and there were very few craters on it because most of the moons and hard planetary surfaces that we find throughout the solar system tend to be peppered with craters. But what you do see on Europa are these fine cracks that run, that crisscross the surface. And at the really highest resolution images, like the one that you saw earlier from Dimitri, those you actually even see blocks that look like icebergs or things that are icy that have shifted over time. And so one interpretation for why Europa looks like this is that the surface is indeed covered by a thick layer of ice, and people don't really know how thick it is. It could be 50 kilometers thick, it could be 100 kilometers thick, so definitely something much thicker than anything that we've drilled through on Earth. Um, but underlying that ice is an ocean of liquid water, and below that is a perhaps rocky surf mantle, and then you could have a metallic core underneath. And there have been some debates about whether there actually is liquid water underneath that outer ice shell, or whether beneath that hard shell you might have kind of like a slushy ice that convects, meaning because the interior is warmer, that you have convective motions where that slushy ice flows up, cools off, and then flows back down. But regardless of which one of these is correct, it seems like a lot of people think that there is a liquid ocean, and some of the estimates for this liquid water inside Europa is up to twice as much as all the water on Earth. So if you think about how big our oceans are, and now you think about a moon orbiting Jupiter, which is slightly smaller than our moon that orbits the Earth, it can potentially have twice as much water as we have here on Earth. And so, as a result, lots of people are interested in studying Europa and perhaps sending a spacecraft there in the future to study it in more detail. And here on Earth, we know that wherever we found water, we also find life. And so one reason why, or one of the primary reasons why people are interested in Europa is to see if life has possibly evolved there in the past or currently exists. And one of the big mysteries is what these cracks, why these cracks are of this reddish color. And unfortunately, the instrumentation that we've had on spacecraft that have flown by or were in orbit around Jupiter, they haven't been able to give us the amount of information to really allow us to guess what this material is made out of. So there have been guesses that this could be sulfur, this could be magnesium, or something really a somewhat heavier element. And two researchers at Jet Propulsion Laboratory in Southern California decided to do an experiment. And here's one instance in the space sciences where instead of looking at or observing photons that are arriving from space, here are actually two researchers doing an experiment in a laboratory setting. So this is very unusual, but it does happen in the space sciences. And what they did was they created a what they call Europa in a can, where they reproduced the conditions of Europa, meaning you replicate the vacuum of the environment around Jupiter that Europa orbits around. And it's also very cold there, so about minus 280 degrees or about minus 150 degrees Celsius. And it turns out that the European environment is also very hard in terms of radiation. So Jupiter's magnetic field traps radiation, and that in turn makes the environment around Europa very dangerous for both machines and living things, or at least on the surface. And so what they did was to replicate that radiation by shooting electrons or beams of electrons at their samples. And their samples are basically salt, sodium. So sodium chloride, table salt or sea salt that everyone here is familiar with. And they had different mixtures of that with different amounts of water. And here in this picture, you can see sort of a slight blue glow around this, and that is actually the electron beam at work. So the electron beam was turned on to try and mimic the radiation environment around Jupiter. And what they found was that over time, they ran this experiment for about 10 hours at a time per sample, and the amount of radiation that came from this electron beam was basically the same as if you had that sample on the surface of Europa for about 100 years. So they basically accelerated what might happen on the surface of Europa. And the longer that they irradiated the sample, the more yellowish it turned. And so by the end, it actually started turning to that kind of orangish, yellowish brown color that you saw in those pictures from the Galileo spacecraft. And so one interpretation then for what is happening on Europa is that they are seeing basically salt that has seeped up from the ocean beneath the icy surface. And the salt, so if you think about Europa as being an icy world with tidal forces from Jupiter heating up the interior of the planet, if a meteor or tides from Jupiter or the other moons managed to crack the surface, then you would imagine that that salt water would seep up through those cracks. And so this experiment suggests one possible interpretation for what we are seeing on Europa. And whether this is actually correct or not, we'll have to await better instruments that can actually do spectroscopy of those features, although the colors that they measured do match what has been measured before from previous instruments at Europa. So that's a really exciting result.